All right, today we're going to look at section 6.3, which is form function operations, which actually we've covered before in class, so it shouldn't be too bad for you. And then we're going to look into this new thing called function composition. So composite functions are not too bad. And hopefully, if I do my job right, we'll see how it segues from the operations that you already know how to do. And then we get into the composition. So the way that we do composition is, I think of it in Inception. So we'll look at that when we get there. First example that we're going to look at today is just basic operations with functions. We do have two functions here. One of them, f of x equals 3x. The other one is g of x equals x plus 3. So f of x equals 3x, and g of x equals x plus 3. Those are our two functions. And what we're doing with our functions today is we're really combining two functions to make a new function. And it'll either say operations, and again, we've covered the operations part, or it will ask us to do composite. And I'll talk about composite in a sec. So first thing I want to look at, again, g of x is x plus 3. That's a function. F of x is 3x. That's another function. The first problem asks us, h of x, create the new function h of x that is from combining f of x and g of x. The second problem says, find the new function h of x, and it's going to come from g of x minus f of x. So many of you guys already know what we're going to do here. Wherever we see a g of x, we're going to substitute in an x plus 3. Wherever we see a g of x, we're going to substitute in an x plus 3. Likewise, we're doing what they're telling us to do. This is pretty much just straightforward substitution. Wherever I see an f of x, I'm going to put what the f of x function is. Wherever I see the f of x, I'm going to put what the f of x function is. Do that one in red. F of x in this case is 3x. F of x in this case is 3x. We've substituted in our functions correctly. Now we just need to perform the operation that it's asking us to do. In this case, it's addition, so h of x will equal 3x plus x plus 3. This becomes a combining like terms problem, and our answer is going to be 4x plus 3. So our new function, h of x, is going to be 4x plus 3. Subtraction, same thing. Our new function h of x is going to equal g of x minus f of x. So h of x is going to be x plus 3 minus 3x. And again, if we had multiple terms there, we would distribute that negative all the way through. In this case, we don't, so h of x is going to equal x minus 3x, which is negative 2x, plus 3. So h of x, which equals g of x minus f of x, is negative 2x plus 3. And h of x, when it equals f of x plus g of x, will be 4x plus 3. Domain. We'll talk about domain restrictions in class. So I just want you to make sure you get the operations down, see what we're doing. Substitute and simplify is really the key to success here. All right, next problem. I want you guys to pause the video right now and do these two problems. I will be looking for the solutions to these two problems when you come to class, in addition to your notes. Again, I'm going to look for the solutions to these two problems when you come into class. So you're to pause the video, do the problems on your own, and bring the problems completed to class tomorrow. All right. Next problem. Rhinos. For a white rhino, heart rate R in beats per minute and lifespan S in minutes are related to body mass in kilograms by these functions. R of m equals 241 m to the negative 0.25. S of m equals 6 times 10 to the 6th m to the 0.2. The directions. Find r of m times s of m. After we find that product, it wants us to explain what it means. So two things that this problem is asking us to do. First off, it's asking us to multiply r of m times s of m. Notice that this is just two functions blending. We're creating a new function here. We're going to take the function r of m, which is 241m to the negative 0.25, and the function s of m, which is 6 times 10 to the 6 m to the 0.2. We're going to combine them by multiplying them. So, r of m is 241 m to the negative point. Oops, let me write that. Dang it. 241 m to the negative 0.25, and s of m is 6 times 10 to the 6th m to the 0.2. This problem is asking us to multiply those two together, so that's what we're going to do. I have 241 times 6 times 10 to the 6th, and that's going to be times m to the negative 0.25 plus 0.2. Again, remember when I have exponents that have a common base and it's asking me to multiply, then I keep the base the same and I add the exponents. That's from yesterday. So multiply 241 times 6 times 10 to the 6th. When I do that, actually I'm going to leave this in scientific notation. That will give me 1,446 times 10 to the 6th. And I'm going to leave that just kind of in, I'll make that a little bit prettier for you. 1,446 times 10 to the 6th. There's almost scientific notation for you. And that's going to be multiplied by m. And then negative 0.25 plus 0.2 is negative 0.05. I'm going to go ahead and change that into scientific notation. In order to change it to scientific notation, I need to move that decimal over 1, 2, 3 units. So it will become 1.446 times, and remember I moved it over 1, 2, 3 units. So this will become times 10 to the 6 plus 3, which is 9. So 1.446 times 10 to the 9, m to the negative 0.05. That is the product of r of m times s of m. So it answers part 1. That's what we're looking for part 1. Next part of this problem, I'll leave that down a little bit for you. Explain what this product represents. In other words, what's happening? Well, we've got a rhinoceros here. And we've got a unit m, which stands for mass. That's how much this thing weighs, body mass. How much the rhino weighs. So we've got how much the rhino weighs and how much the rhino weighs. What this equation is relating is beats per minute, that's a heart rate, and then lifespan in minutes. And we can predict, basically, beats per minute and lifespan. And that will give us a grand total of how many beats the rhinoceros will have in its entire life. Again, beats per minute times the number of minutes should give you the total number of minutes. In this case, you're talking about lifespan. So how big the rhinoceros is, times the beats per minute times the lifespan will give you total beats in the life of a rhinoceros. So there's your sexy equation for the number of beats in the total life of a rhinoceros if we had its weight. Next up. I'll give you guys a couple seconds to copy this down. You're probably going to want to pause the video. I kind of talk while you guys are writing this down. Composition, this is something new for you guys. It's not that hard. It is tricky at first, but there's definite patterning for it. This is also out of page 430 in your textbook if you want to see this diagram. But the way that I think of it, if you guys have seen the movie Inception, which is kind of a dream within a dream, that's kind of what these problems are. It's a function within a function. The way that you're going to hear these talked about is they're called g of f of x or f of g of x. So g of f of x is what this is a diagram of. We're again creating a new function based on what they're telling us to do. They're telling us to do something different in this problem, though. And composite functions work this way. We work from the inside out just like we do with PEMDAS. So in this problem, it's saying start with the function f of x. So start with the function f of x, and that's what we've got. We're going to take some number, and we're going to input it into the function f of x. We're going to do whatever f of x tells us to do. So that's going to give us some sort of output. In other terms, x comma y. We're looking at our y output. So I get whatever f of x is, some output. Then, since it asks us to find g of f of x, it's not asking us to multiply. That's the common mistake. In this case, it says take your output from the first function, the f of x, and input that number into the other function, the g function. Rerun that function notation, and you're going to get the output there. Basically, you're putting it into both functions. I'll show you how it works. This is a little confusing, but I'll show you how this diagram relates to the next problem. Again, read it as g of f of x and realize that we're going to start from the f of x and then we're going to apply that to the g of x. Okay? Again, a function within a function is the way to visualize it, just like a dream within a dream from the movie Inception. We've got two functions. Once again, f of x equals 6x minus 1. F of x equals 6x minus 1. And we have g of x equals 3x plus 5. F of x equals 6x minus 1. G of x equals 3x plus 5. The first thing they're asking us to do on this problem is to find g of f of 2. As I told you, you're going to start from the inside and work your way out. Since it told us to start in this problem with the function f of 2 first, that means to take the function f of x, which equals 6x minus 1, take f of 2. We know how to find f of 2. That's 6 times 2 minus 1. F of 2 becomes 12 minus 1. F of 2 equals 11. So again, a function within a function. We found f of 2. We started with f of 2. By the way, hopefully you say this with me at home. F of 2 equals 11. Repeat it with me. F of 2 equals 11. So what I'm going to say is f of 2 equals 11. So this composite function, or a function within a function, means find the first one first and then do the next problem. In this case, it's asking us really to find g of 11. It says find f of 2 first. F of 2 is 11. F of 2 is 11. So now we need to find g of 11. G of 11? Well, if g of x equals 3x plus 5, then g of 11 will be 3 times 11 plus 5. So g of 11 is 33 plus 5. G of 11 is 38. And notice that's a function within a function. So here's how we'll write our final answer. G of f of 2 is 38. Mr. Wood, that's not that hard. You just take the answer and put it in the next one. Yep, that's what I'm saying. So the second one, it actually says f of g of negative 3. All I have to do is stick the negative 3 in the g function. And then I take whatever that answer is and plug it into the f function. And I just have to pin process and get it right. So it's really that easy. So this time, we're going to start with g of negative 3. I need to start with the g function this time. Sounds like the name of a band. That's your password for your notes, by the way. What's the name of the band in composite functions? The answer is, the name of the band is G function. G function is the name of the band. That's your password for today on your notes. All right, f of g of negative 3 is what we're going to do. We need to find g of negative 3. G of negative 3, I'm going to do it right up here. Starting from the inside and working out. G of negative 3, 3 times negative 3 plus 5. That's negative 9 plus 5. Negative 9 plus 5 is negative 4. So G of negative 3 is negative 4. So G of negative 3 is negative 4. So now this is asking me to find f of negative 4, or f of G of negative 3. F of negative 4, f of x is 6x minus 1. So f of negative 4 is going to be 6 times negative 4 minus 1. So f of negative 4 will be negative 24 minus 1. F of negative 4 is negative 25. So the answer to this composite function, which is f of g of negative 3, is negative 25. And that's what we're looking for. Again, hopefully you see what I'm talking about now. A function within a function, you take the output and put it into the next function. I'd say any questions, but since you're listening to the video, I can't answer them right now. You can bring your questions next to class tomorrow. Same functions. I think it is. 6x minus 1 and 3x plus 5. Still same f of x, still same g of x. Still same f of x, still the same g of x. The first problem asked me to find f of g of a number and g of f of a number. In this problem now, they're not asking me to do that. This now wants me to say, find f of g of x. F of g of x. Well, it means to take what g of x is and put it into the f function. So once again, Mr. Wood, I don't know what g of x is. Sure you do. F of g of x is 3x plus 5. So this problem is asking me to find f of 3x plus 5. All I did was stick what g of x is into the f function. So here's, and this is kind of where it's tricky for students. So I'm going to write the f function, which is f of x equals 6x minus 1. To do the composite function, which is f of g of x, it wants me to find f of 3x plus 5. That's f of 3x plus 5 equals 6. I now need to put in, anytime that I had an x before, I will be putting in what my substitution is, which is 3x plus 5 minus 1. That is now f of g of x. I put in g of x everywhere there was an x in my f function. So all I have to do is work the right-hand side there. Distribute 6 times 3x is 18x. 6 times 5 is 30, and that's a minus 1. That becomes 18x plus 29. That's my answer. That is what f of g of x is. 18x plus 29. That's not that bad. Nope. G of f of x. G of f of x, doing the second problem this time. This time I'm going to start with the f of x. F of x is 6x minus 1. So this is asking me to find g of 6x minus 1. Notice that these problems are similar, but they are different. Now I need to find if g of x is 3x plus 5, and I want g of 6x minus 1, then that's going to equal 3 times 6x minus 1 plus 5. Taking the f function and putting it into the g function. G of f of x. I'm going to work the right-hand side, distribute in. 3 times 6x is 18x. 3 times negative 1 is negative 3. Add 5 to that. 18x minus 3 plus 5 is 18x plus 2. So, g of f of x is going to be 18x plus 2. Okay. One of those, g of f of x, 18x plus 2. The other one, f of g of x, which is 18x plus 29. All right. New functions, same game. I'm going to go a little bit faster, not necessarily show all that work on these. F of x equals 2x plus 5, and g of x equals negative x plus 6. I'll give you guys a second to copy that down. Again, f of x is 2x plus 5, and g of x is negative x plus 6. Both sides, we're going to find f of g of x and then g of f of x. Starting with f of g of x first, that's going to ask me to find f of negative x plus 6. Again, g of x is negative x plus 6. I know that f of x equals 2x plus 5. This problem is asking me to find f of negative x plus 6. That is what I'm going to substitute in for my x values for my composite function. If f of x is 2x plus 5, then f of negative x plus 6 is 2 times negative x plus 6 plus 5. Simplify. We don't do anything to the left-hand side. We just work the right-hand side. That gives me negative 2x plus 12 plus 5, which is negative 2x plus 17. So on this problem, f of g of x is negative 2x plus 17. Bottom problem, g of f of x. This time we're going to start with the f of x. F of x is 2x plus 5. We want g of 2x plus 5. G of x is negative x plus 6. I want g of 2x plus 5. That's what I'm substituting in for x. So that's going to say negative the quantity 2x plus 5. Again, there's my substitution. Plus 6. When we're doing composite functions, we don't work the left-hand side. We only work the right-hand side. I'm going to distribute that negative through. That's negative 2x minus 5 plus 6. Negative 2x plus 1. So g of f of x, g of f of x is going to equal negative 2x plus 1. Function inside of a function. All right, another set of checkpoints for you guys right now. This is the time where you go ahead and pause the video, work those problems, and I'm going to want to see the checkpoints, answers, with work when you come into class tomorrow. All checkpoints with the notes. That's what I want to see. I will give you the checkpoint answers tomorrow during class. So pause the video, do these problems. When you're ready to move forward, go ahead and unpause the video. Last problem. It's a lot of writing. This problem is in your textbook, so if you don't want to write the whole problem down, that's okay. I'm more concerned about the work here, and I want to hopefully relate this to the composite functions that we've been doing. So, in the paint store, you've got a $10 gift certificate. The store is also offering 15% off your entire purchase of any paints and painting supplies. You need to purchase a $30 can of paint and $25 worth of painting supplies. Problem says, use composition of functions to do the following. It's asking us to do two things. Find the sale price of your purchase when the $10 gift certificate is applied before the 15% discount, and then find the sale price of your purchase when the 15% discount is applied before the $10 gift certificate. As I read that through, many of you guys probably said, well, aren't they doing the same thing? And the answer is no, they're not. Okay? So I'm going to look at this in terms of composite functions because that's what we've been talking about today. So I'm going to kind of write that down. I'm going to look at this. My first function, it's going to represent the $10 gift certificate. So I'm going to say f of x is going to be the $10 gift certificate. So in other words, I get $10 off. So if x was my cost before, then f of x is just going to be $10 less than my price. So that's my function. So my red function, which is f of x, equals, I'm just going to write $10 discount. Or I'm going to say gift certificate. Discount's the wrong word. All right. And then my other function, I'm going to make that in green. Apparently it's Christmas. G of x is going to be my 15% discount. So how do I give a 15% discount? I take how much it was, which was x. I don't know how much money I spent. But then I subtract 15% of it. 0.15 is 15%. You guys remember that from the compounded interest. 15% is 0.15. So x minus 0.15 is going to be my cost, which was x, minus a 15% discount. So g of x as a function is really going to be x minus 0.15x, which is going to be 0.85x. So my g of x function is going to be the cost, and that's with a 15% discount. Now let's look back at the wording of these problems. The first bullet says, find the sale price of your purchase when the $10 gift certificate is applied before the 15% discount. $10 gift certificate is applied before the 15% discount. In other words, the first bullet, and I'm going to number these for you. I'm going to say that this is, I'm going to say bullet number 1. Okay? Bullet number 1 says, find the sale price of your purchase when the $10 gift certificate is applied first, and then the 15% discount is applied second. So it says this. It's really saying g of f of x. And make sure you can get that wording. If you understood composite functions as we did them today, then I'm starting with f of x. F of x is the $10 gift certificate. I'm doing that first. And after I take off the $10 gift certificate, the next thing I'm going to do is give myself the 15% discount. So hopefully you'll see how g of f of x matches in the context with this problem and matches to what we just did on the previous problems. Okay. G of f of x. We're going to start with our f of x. F of x is x minus 10. G of x is 0.85x. So this problem is really asking me to find g of x minus 10. G of x equals 0.85x, then g of x minus 10 is going to be I'm substituting in for my x's here. g of x minus 10, there's g of x minus 10, which is g of f of x. So this function becomes 0.85 times x minus 10. So g of f of x is, and I'm just going to leave it as 0.85 times x minus 10. You can multiply that out if you want. It'll become 0.85x minus 8.5, I believe. Okay? So that's g of f of x, which hopefully makes sense in terms of sale price of your purchase when the $10 gift certificate is applied before the 15% discount. And now for bullet number 2. That's this one here. Find the sale price of your purchase when the 15% discount is applied first, and then the $10 gift certificate. So hopefully, right now, you're seeing the patterning, and we're saying, hey, this time it wants me to take the 15% discount first, which is g of x. After I find the 15% discount, take the $10 off. So this one's asking for f of g of x. That's what the second bullet was talking about. So again, g of x, that's what I'm looking for. G of x is 0.85x. So this problem's asking me to find f of 0.85x. Again, g of x is 0.85. F of x equals x minus 10. Then f of 0.85x is going to be 0.85x minus 10. And that's going to be f of g of x. So f of g of x is going to equal 0.85x minus 10. Now I have both of the composite functions. One of them is taking the discount first. One of them is taking the $10 off first. Okay. Problem actually said, find the sale price of your purchase and find the sale price of your purchase. Well, how much stuff did you buy? We bought a $30 can of paint and $25 worth of painting supplies. So hopefully you'll agree with me right now that we actually spent or the stuff that we wanted to buy was worth 55. Was worth 55 bucks. But then I had the $10 gift certificate and 15% discount. So really I want to know how much I paid under both these scenarios. So if g of f of x is 0.85 times x minus 10, and f of g of x is 0.85x minus 10, I can find both of those values. In other words, let me find g of f of 55, which is going to be 0.85 times 55 minus 10. And g of f of 55 is going to be 0.85 times 45. That was 55 minus 10 there. 0.85 times 45 comes out to be 38.25. Just calculator crunch on that. Other function, f of g of x is 0.85x minus 10. I'm looking for my cost there. F of g of 55, that's going to be 0.85 times 55 minus 10. And that one will come out to be, f of g of 55 will come out to be 36.75. So, 36.75 compared to 38.25 saves you a couple bucks-ish if you go the second route, which is 15% discount first and then the $10 gift certificate. 15% discount first, then $10 certificate will be cheaper by about $2. Those are your two situations. Okay. That's about it. You guys are done. Don't forget to finish up your homework if you haven't done so. Good luck. See you guys mañana.